just love khaki love. There's one khaki love. He's one of the most and
Okay. Good morning, everyone. Can you guys hear me all right in the back, Millie? Cool. Sorry for messing with this while it's on. Okay. Yeah. Welcome back from spring break. Sorry I'm a little behind. I lost track of time upstairs, which doesn't usually happen. But I was getting ready for today. I'm really excited to talk to you all today about code organization. And how that works in SwiftUI. So we're just going to be talking today, no coding, so we don't need laptops. Again, I understand the urge to just work on other things, but we're all here to learn. I think it's best if we put our laptops away and just, if you want to take notes or something, you can. But yeah, no laptops. Okay. So a couple logistics things. I'll be putting up a quick short reading later today. That'll be due tomorrow. I forgot to write that. Due tomorrow. Sorry about the quick turnaround. That was like the feedback on the feedback form. I planned to get a lot done over spring break, but my family was insistent on doing stuff during our vacation. Speaking of the feedback form, we didn't hit 90%. We didn't hit 90% completion on that, which was the target. I'll figure something out for that. That was a little bit of a bummer. Then our next big project is going to be a bigger networking project where we do some code organization stuff. I'll get details out about that later this week, and that'll be due sometime next week. Then I guess also the midterm redos, I started grading those over spring break, and we're going to finish those up soon. So expect those sometime late, expect to get back your redo score and your sort of normalized final midterm score sometime later this week or early next week. So a lot of stuff coming down the pipeline. This is a pretty bad Monday. This Monday is Mondaying pretty hard after spring break. But yeah, we're going to get back into the swing of things and have stuff coming down quickly. Okay, so today we're going to be sort of thinking about code itself. And most of the time, at least for me, especially in 110, 210, code was just a tool that I was using to achieve some behavior, right? And the kinds of things that you would do, especially back then, are write a function that squares a number and returns a result, or make a linked list. And we just hit the autograder tests, and I would do whatever I could to pass the autograder tests, and had no sort of care in the world about what my code looked like or how it was set up. And sort of up through this point in the class, we've sort of taken a similar approach, more or less, where I just say okay, here's the requirements for the app, write the code, and however you set it up doesn't really matter. And I've sort of given guide rails and stuff, sort of set things up to keep you on a pretty decent path, but we haven't really talked much about the code itself. But the sort of question we want to talk about today is, if the code is behaving correctly, does anything else really matter? And hopefully you can tell the answer is yes. So remember last week, or I guess the week before spring break, we built this Notes app, right? And here's the code for the Notes app. I could not fit it on one slide, let alone, I think it took me 5 slides to put all the code there. And so yeah, there's a lot going on in that code. And sort of get us started today, I want us to think back to the code that we wrote on, I guess that was two Wednesdays ago or something. Think back to that code. and just sort of very abstractly, like answer the question of like what do you think about this code that we wrote? So like thinking past the functionality, like the code itself, what do you think about how it was set up, how it was organized, if you liked how it was organized, anything. It's very abstract on purpose. Yeah, so let's take like about a minute to just sort of jot down some notes on your paper, and then we'll sort of compare with the neighbor in a minute. So take a minute, just write down a sort of bulleted list of things you thought about the code in general. So yeah, for now, just individually write some stuff down. We'll talk with other people in a minute. Okay, that's a minute. Talk to your neighbors, and maybe think about some 301 stuff. I think the informal title for 301 is Organize Own Code. Very compelling title. Yeah, so maybe some ideas from 301 might be interesting here. So yeah, talk to your neighbor, compare thoughts about what you think of the code from the Notes app. Okay. Hopefully you were able to talk about something with your neighbor. For the sake of time, we're going to move on. So, yeah, whoever's sitting in or near G4, A, B, C, D, E, F, G. Okay. What was an idea that you had?
I said that I really liked that the variables were set up at the top instead of like you randomly setting up a struct in the middle of your code and then forgetting where you said about that.
Cool. Yeah, so you like that the variables are at the top, separated from everything else, when there's really nothing keeping us from just putting them all over, mixing them in with the method definitions. Cool. Any other thoughts from the Notes app code? Or, I don't know, I did that. Whoever's sitting nearest to B5, which is like no one. What you got? Yeah. What was an idea you had about the code?
They had lots and lots of subclasses.
Not from 301, like from the Notes app that we made. What? That's okay. Next person, H6. Where's row H? I think it's one behind. Okay, yeah.
I think I thought that it was fairly simple to figure out. Like, it was well organized.
Okay, it was well organized. Any critical thoughts? We can just stop seat generating. Yeah, Jason.
I had really little abstraction. Like everything was kind of in one spot. It was hard to digest.
Yeah. All of our code was written in this one view struct with no. Have you heard the term layers of abstraction before? Yeah, there's no layers here. It's all just flat. Any other thoughts from anyone? I heard other people saying stuff. Like I heard other things.
I like that the UI and networking were at least separate with like tasks, but I agree that it's still kind
Yeah.
At least visually they were.
So yeah, I'm noticing some things. It's like we didn't do, or else I'll just cut ahead to my thoughts. So yeah, there's a lot in this code. I tried to fit it. This is how I could fit it on one slide. It's very long. So the first thing that I came up with was like, this code works, and there's nothing like wrong about it, right? Like, we made a notes app. You can type notes in, save notes, delete notes, view notes. You know, it like all works. There's nothing wrong necessarily, but there's some other things to consider, like past the functionality. First, this is just like a long file, right? My implementation was, let me see, I didn't mean to quit it. My implementation was like 147 lines. There's nothing bad about like length of a file in general, but like for a pretty simple app, that's kind of getting to a lot of lines of code for one file. That's kind of unavoidable. And if you've had like internships and worked in industry, you've probably seen some terribly long files. But that's just one thing I noticed. Like, there's just a lot of code all in one spot. Other thing is that there's just a lot of different kinds of things being done by this code, right? Like, we're displaying the list, making the network requests, updating the UI, like all sorts of different kinds of tasks that are happening all in one place. None of this code is reusable, right? That's sort of like what Jason said, where it's all just in this one view struct, and like later on we'll see some stuff where it might be helpful to reuse some code. That's impossible here. And this is probably a bit out of scope for this class. Like, we probably won't be writing mini tests of our own in this class, but if you go to industry, a lot of companies have like requirements about testing and meeting certain code coverage expectations. And this is very hard to test. One, there's like the strict dependency on the actual API, and two, it's all in the view, and SwiftUI view testing right now isn't very good. So like, if your company is asking you to test your code, you'd have a hard time doing it here. So yeah, those are some things I noticed, and a couple of them I think are more important. The first is reusability. We'll see more use cases for this later on this semester when we start building bigger, like multi-part apps where we'll want to reuse code throughout the code base. And one example I can think of is like if we wanted to add a widget, like an iOS home screen widget to this app, that code will want to like display the same list of notes and make the same exact network request. But right now, all that networking code is directly in that view struct. And if we wanted to use it in the widget code, we'd have to like copy and paste and have like a duplicate parallel implementations of the same thing, right? Which isn't great. So one thing we might want to think about achieving is sort of breaking all that stuff out into its own component that we can reuse in multiple spots in the app. Other thing that we might, or that I noticed, another big thing I noticed was that there's a lot of different responsibilities being performed by this one file, right? We're directly interacting with the API, right? Like sort of handling the authentication, sending up the API keys, decoding the data, using URL session, setting the headers, like all of these sort of very specific networking concepts are happening in the same file that's managing the app state. So like in this app, we have the state variable with the notes array. When we have successfully made the post request to save a note, we append to the array. When we delete something, we remove the items from the array. And I added this later, but like after I save a note, I clear the text field, right? Just so it's nice and easy to add a new note after. And then we're also displaying the data, right? We're displaying the note saying that it should, like in the for each, having the text and the timestamp text with secondary foreground style with a footnote font. There's like, that's sort of completely a different kind of concern from the sort of networking stuff, right? And all of this is all in this one file. And you guys are right, like we did sort of section it out to sort of put like things together, right? We had our state variables at the top, then our view, then all of our networking code. But number one, there's nothing keeping us from like taking this state variable and putting it down at the bottom, right? Or doing all sorts of funky stuff that would make it really hard to reason about this code. So yeah, we have all of these sort of different kinds of responsibilities being managed in one place, which is weird. So one really common way to handle this and to sort of organize our code in iOS is MVVM. Does this acronym remind you of something, perhaps, from 301? What is it? MVC? Yeah. 301, I think, was, for me, like, it was a nice conceptual introduction to MVC, but I didn't really walk away with a lot of understanding of how to use it. So hopefully we can sort of throughout this week take another look at something MVC-like. And like MVVM is basically MVC, but changing the C to a VM. But it attempts to sort of address some of those issues that we had with the Notes app code, right? Where we had this lack of reusability, all of our different responsibilities in one file, which doesn't have any separation of concerns. Have you heard that term, separation of concerns, before? It's like, okay, we're going to have different parts that are each concerned with a different kind of thing, and so each like individual part can be very focused and only talk about one kind of task, basically. And MVVM also enables better testability. And we do this by sort of splitting all of our code into these 3 different layers, which sort of brings back this like layers of abstraction kind of deal. So we've got these 3 different layers. First is the model. This is sort of our representation of the data and all of the logic that we need to sort of get like sort of grab the data from wherever it is, whether that's like in a local database or on a network, like or sort of in an API or multiple APIs, just like the logic that we need to grab that data, send new data up. And importantly, this is sort of totally UI independent, right? It's just sort of pure, like, okay, for the Notes app, like sort of taking the API spec that we had, like this is a post request that needs this API key and this data be sent up in this format in the like request body, taking that API spec and implementing it and not having any direct sort of coupling to the UI or like where that data is going to end up. So it's just totally independent. And this is where like our sort of Notes app widget thing could be used. Like we could have in our model layer just the code to fetch from the API, and whether that gets displayed in the main app or the widget or outputted in like a shell script or whatever, it doesn't really matter, right? It's just sort of this pure data layer with no sort of notion of where the data is going to end up. So that's the model layer. Then we have the view layer. This is sort of like first few weeks of class, right? Displaying information, handling user interaction, and there's this fun sort of thought in the community of like, this view layer should be really dumb, right? It's just like, okay, you give me data, I put it on the screen, I have no clue where it came from. Then when the user taps on something, I just say, okay, something happened, do something. What actually happens past that point doesn't matter, right? To the view, basically. Like that's like sort of meta point here that might seem silly, but like all of the programming you've ever done like really relies on this like sort of abstracting away implementation details thing, right? And one thing I found to be interesting as I did my like computer science major was peeling away these layers of abstraction and getting down to like in 541, 311, like how does the how does the CPU work? And even there's even abstractions there because we're like ones and zeros. CPU doesn't know anything about ones and zeros. It's electricity and like physics stuff, but like the computer scientists sometimes don't need to know about that. We just need to have this nice abstraction of ones and zeros. And then the electrical engineers who build the chips, like they actually care about that stuff. So like this might seem silly, and when you're like writing all this code yourself, you can be like, I don't need to have layers of abstraction. But this idea of having several different abstraction layers where you can sit on top and just benefit from like having a very simple model of the world below you is really important, and like is the reason that you can write code on the first day of Comp 110. Yeah, so the UI layer is really dumb, displays information, and handles user interaction. And then in between the two, we've got this middleman that we call the view model. This would be the MVC controller. MVVM calls it the view model, which is, I guess, aptly named. And this sort of takes information from the model, like sort of cleans it up, and spits it out to the view, right? So the view can display it without any sort of, the data might come back in some weird format or whatever. Like it might have a lot more than the view needs or whatever. Maybe stuff needs to be combined. So the view model will just sort of do some stuff with the data, get it ready to be presented by the UI, and then in the other way, sort of take some user interaction, tidy it up, send it to the view model, or send it to the model, sorry, in a way that it expects. And sort of while doing this, it manages the app's state, right? So yeah, this is sort of intentionally vague because I want you guys to sort of start thinking about this and start trying to apply some of the stuff that we talked about in the Notes app thing just a minute ago and putting them into the separate layers. So let's do a similar thing that we just did. Let's take like probably a minute and a half or so. I want you to write these 3 headings on your paper: model, and view. And then under each of those headings, I want you to sort these different tasks that we had from the Notes app. So yeah, let's take a bit to do that. A minute and a half to do that on your own, then compare with your neighbor. Okay, yeah, we'll come back in like 90 seconds. think about one more minute or so. That'd be good. Any response? Okay. A little longer. And I just want you to like give it your best shot. Like you don't have to worry about being exactly correct. I just want you to start thinking about it. Okay. Let's take like 2 minutes to compare with their neighbors. Make any changes you think you might want to do. Like we had the state variable, the notes array. Yeah. Let's take like 20 more seconds. Okay. We're gonna sort of work through this together. It's okay if you didn't finish all the way. Yeah. Who found that to be easy? Not easy? Doesn't have any thoughts in their brain right now? Yeah. Let's try and have thoughts in our brains. And try and help me out by participating today. So, if I were to, I could say that I made this hard on purpose. That's like halfway true. One point that I think is really important to make when talking about code organization is like, there's no one way to do it. And even when you have like subscribed to one system like MVVM, there can be ambiguity. And like I was trying to look up articles and stuff that, like look up articles to share with you all about MVVM, and I couldn't find one that like really was good and consistent, and like everything was different. Like every different article did it in a different way. So the idea I want to get to y'all today is like there are ways to organize your code. MVVM is one of them, and like within that, there can be differences. So like you might disagree on where something goes. Like from one week to the other, I might disagree with myself, but I want you to start thinking about ways to organize your code and separate it out, because that will just end up with better code bases in general. Okay, so let's just sort of walk through this. Yeah, the first one might be the most confusing one. I just sort of went into a like list order randomizer to make this order, and it kind of messed us up a little bit. Yeah, I would bet, like now write this better as like clear the new note text. Yeah, where does someone think this should go? Clearing the new note text after saving a note. Jason, the view? I'd put it in the view model. Yeah, and we'll walk through this in a minute. Yeah. I'd say that's the one place it might like definitely not go, because and that's okay. So the idea here is like the model layer for this. Let's finish walking through it, and then we'll sort of have some meta thoughts about decoding the data from the API. Any ideas, Ben? The view model? Any other ideas? Jake? Yeah. Yeah. I'd put that in the model there. Okay, what about making the actual network requests? Any ideas? Model, yep. That's where I would agree. Okay, adding to our, let's skip ahead to keep track of the notes list. And this, I mean like the array. Like in the old one, we had the state property, like the notes array. Where do you think this might go? Okay, yeah. So I would say the view model here. And I think this is sort of a difference between like the notes array and like the notes database, right? Like the like canonical list of notes is like stored on the server, right? Like away from the app entirely. And here we're just talking about the app in general. And the model in this case, I'd say, is like responsible for interacting with the API. And if you remember, our API just had like fetch the notes list, save the notes list, delete. So I would say that the view model is sort of making those API calls and keeping track of the notes list that the view will display. And yeah, I hope this will make more sense in a minute. Next, adding to the list after creating, removing after deletion. Hopefully this should follow after the last one. Any ideas?
View model.
Yeah. Yeah. So yeah, I would put like appending and removing from the list, or from the array, squarely in the view model. Handling authentication. Any ideas? Low stakes here. Any ideas?
Model.
Yeah, the model. That's like a sort of purely API driven construct, right? Like the fact that, I mean, I don't know why my pencil just stops working right when I'm up here. It never happens otherwise. Yeah, sort of the authentication, the API keys are like a purely API spec construct, right? Then as we've implemented it, the UI doesn't need to know anything at all about the fact that they're API keys. Then the last two, displaying the notes list and managing this text field in the button. Yeah, that's the view. So this is like actually showing stuff to the user and handling user interaction. Okay.
Just the last one.
Yeah.
Would the model not have like any copy of the array when it's decoding between JSON?
So this is one place for ambiguity, and it kind of depends on the context. But the way I would think about it for this project is that like the model layer is basically just functions that you can call. Right? You can call the fetch notes function. You can call the like delete note or save note function, and there's sort of no state there. It's just the way to interact with the API. And even then, like, we'll need to have the array in a way that that the view can use it, like kind of like a state property, but there's a little bit of a different way that we'll be doing it here. It's like, yeah, that's one case where in this app, I'd say that the model is just sort of some function calls that we can make. And then the view model sort of like builds a nice complete picture of the current state of the world for the view by managing that array. Yeah, but some other, like, some of those things where sometimes, like, the model does have an array in it, and it's just weird, and it depends on the project and the specific part of the project you're working on. Yeah, so I think most of the confusion here was in here, right? And so, like, where should decoding the data go? Like, I'm talking about like decoding the capital D data, like from like with JSON decoder, right? That's sort of purely talking about the API spec, the way that the API said its response body was going to be formatted. I think that sort of lives in the model completely. Then this stuff is where it gets a little tricky, and all of this is sort of managing state and like sort of keeping track of what the view should be showing. And remember, the view should be really dumb, right? It should basically just take something that the view model gave it, display it on the screen. If the user taps on something, just sort of really quickly punt responsibility over to the view model who's going to like actually do something with it. And this like clearing of the notes text is sort of some state management stuff. So I'd leave that in the view model. Any other big picture questions here? Okay. So yeah, that's an interpretation of where things go. There are other versions that could be fine, you know, but I think it's good to sort of draw these lines of like dealing with the data, managing the state, cleaning things up, getting them ready for the view, and then the view just literally displaying what it's told to display and handling user interaction is nice as you're getting started. Okay. Okay. So now you can go ahead, get your computers out if you need to submit a picture of your photo, or submit a picture of your paper as the attendance submission for today. So just write your name, your PID. You don't need to write your seat number. It's fine. Okay, just your name and your PID, and the like sort of notes that you have from today's activities. Cool. So go ahead and do that. While you're doing that, I want to talk about what's coming next. So in the reading that we're going to do, we're probably going to learn about some of the tools that we'll need to implement this. And on Wednesday, in some fashion, we'll sort of take a first look at taking the Notes app and MVVMing it. Sort of separating out all the stuff that we had in the view originally and making the different components. So yeah, that's what we'll be doing on Wednesday. And for tomorrow's reading, it'll be getting familiar with the tools, maybe a quick review of these concepts. Cool. Are there any big picture questions that people have right now? Okay. So yeah, go ahead and finish up that attendance submission. And then, honestly, I think that'll be it for today. So we can get out a few minutes early. Yeah. Hope you had a good spring break. Happy St. Patrick's Day. I am wearing more green than is necessary to avoid being pinched. I'm traumatized. Okay. Have a good rest of your day. I'll get an announcement about the reading out very soon.